In the previous chapter, we mentioned two types of access control modifiers, public and private. In this chapter, we will introduce you to two more keywords that are also used as access control modifiers. They will be discussed in the next section, which covers information hiding and encapsulation. Information hiding and encapsulation compared. Information hiding is one of the key features of the Java programming language and object-oriented programming. You have already been introduced to this concept where we covered concepts on data abstraction. Simply put, an object in Java will usually hide how it implements its own functionality. Now, in order to do that, you'll have to make use of access control modifiers. Here are four of them: public, private, protected, and default. You are already familiar with the first two, public and private. When the variable is declared to be public, then it can be anywhere in the program you are writing. In contrast, when it is private, then it can't be seen or accessed anywhere else but in the body of the class where it has been instantiated. Let's move on to the other two access control modifiers. The next one on the list is called protected, which is useful in case you want to create libs. When a variable is protected, it means that it can only be seen within the package where this Java construct has been instantiated. Note that this also includes all the subclasses. The default access control modifier, on the other hand, is used by the variable when the other three aren't specified. In this mode, a variable can be accessed within package or class where it has been instantiated by the programmer. However, do take note that the variable is only accessible within the main body of the class and it is not available within its subclasses. Note that you can also create an object within a method, and the usual rules apply. The object or variable can only be accessed within the body of the method where it has been created. Here's another important point that you should remember about variables that you create within a method. It can only specify one keyword for it: final. You will not be allowed to create a default, protected, public, or even a private variable within the method body. And that is basically how information is hidden in your code, which, if you observe, facilitates data abstraction and encapsulation. Encapsulation? Information hiding? What's the difference? It would appear at first glance that encapsulation and data or information hiding may look the same, but there is indeed a subtle difference between these two terms. Now, Nat Price and Steve Freeman have made quite an accurate distinction between these two, although you may read from other authors who use these terms interchangeably. We'll use Freeman and Price's descriptions here to draw the difference between these two concepts in Java programming. Let's begin with information hiding, since that is where we left off. You can already judge what information hiding means. It simply means information is concealed. The actual functions and procedures performed by the program are concealed. But for what purpose? Why are the inner workings kept hidden from the programmer? The lower level details are ignored so that you, the programmer, can focus on much more important things. That is also why data is abstracted in Java. You can create classes, objects, and other elements of your program. You can even import objects from one program to another without worrying about the details on how that object does what it does. It's like driving a car. All you need to know is that when you insert your key into the keyhole and start the car, it will start. You don't have to worry about what makes it start, how the wires are connected underneath there, where the gas goes, how the engine burns the gas, etc. All you need to worry about is starting the car and driving safely. Encapsulation, on the other hand, allows the user to control the amount of change in an object, and can affect the other parts of class. The term encapsulate means to enclose everything in a singular cell. That means that given the way the Java programming system is designed, there will be no expected dependency from one independent cell to another. Remember that objects within the Java programming environment are meant to be standalone, and there are no global variables to reference. Inheritances and subclasses in Java programming. Earlier, we mentioned classes have subclasses. We'll look into that in this section. We have already indicated in this book that objects in Java may have certain traits of characteristics common to a group, especially if they are related. For example, let's say we have the following classes: tricycle, road bike, tandem bike, BMX bike, and mountain bike. They will all share the same qualities and functionalities, such as pedal cadence, speed, number of passengers, etc.